Okay, welcome everyone. My name is Kevin Libwit, and this is the final video of our three-part tutorial series on external applications for the CLC Genomics Server platform. And in this video, we'll be using the same three-step approach that we detailed in the first few videos to write a third external application, this time for Raxaml, a maximum likelihood tree builder written by Alexandros Stamatakis from the Heidelberg Institute for Theoretical Studies. And so as we wrap up this series, hopefully throughout these videos, you've been able to gain a stronger understanding of these genomics server external applications, and you can start seeing how you might implement this process to extend your genomics workbench toolbox to include really any analytical tool that your laboratory may need access to. And so just as a reminder, here are the three steps that I take to writing these external applications. And this is what we'll be working through again in this video. So first here, installation of the tool on the CLC Genomics Server environment. Then we're going to be writing a shell script to wrap this tool into a single and static executable. And then third is the configuration of the external application using that CLC Genomics Server web interface. All right, and so with that brief intro, let's jump into it. Okay, so the first step to writing this RAxML external application is the installation of RAxML onto our genomics server environment. And just like in our previous videos, here is my CLC genomics environment with my terminal here on the right and that web interface here on the left. So now that we have this, let's again full screen the terminal so we can get into the installation of RAxML. And in taking a look at the StaffB Docker Hub, they again have a Docker image already available for us to use that we can incorporate for our external application. And you can see here that just a single RAxML Docker image is available, and this is exactly what we need for our external app here, version 8.2.12. Okay, so let's go ahead and navigate to that Singularity images directory that we created for MAFT and IVAR, and then let's build this RAxML image. So I'm going to use again the sudo singularity build command, and then we can call this RAxML, and it was version 8.2.12 .singularity image. And then I'm going to specify that it is a Docker image that we're basing this off of from that StaffB repository, RAxML, and then that 8.2.12 tag, and let's let that build. And so this should only take a second here. All right, so now that that is done, the next step is to ensure that we can run this container with Singularity to execute RAxML without root privileges. So now let's test the functionality using that singularity exec command. Then we're going to specify we want that RAxML image, and our command just to test functionality here can be RAxML HPC with that H flag. And there it is, perfect. So now we've got RAxML on our environment, and just show that it can be executed without root privileges. Step one is complete. Okay, now, so the next step is to write a shell script to wrap RAxML into a single and static executable. So let's start by defining exactly what command our workbench users will execute when using this external app. And there are a million different ways to run RAxML, but for this example, here is how I want my workbench users interacting with this specific external application. So when users pull up this RAxML external app from their genomics workbench side, this is the command that they'll be executing under the hood. Okay, so walking through this first bit here again is our singularity exec command to run a container based on the StaffB RAxML image that we just built. And the second half indicates the full RAxML command. So this RAxML HPC being the main executable for RAxML. I set the M flag or model to GTR gamma, indicating that we will be using the general time reversible model for nucleotide substitution under a gamma distributed rate variation. This S flag indicates the input sequence alignment file. This P flag indicating a random number seed for the parsimony inferences. And this N flag here indicating a name to append RAxML output files with. I've set this to GTR gamma, which is helpful for me to remember the model of evolution and variance used to generate these trees. So at the end of this, in accordance to the RAxML documentation, I expect an output file called RAxML_besttree.gtr gamma to be produced. And so that is what I'll use to configure this application in step 3. All right, so to give Workbench users access to this command as a Workbench tool and to make the external app configuration process as straightforward as possible, let's wrap this all into a simple shell script that the server can execute. All right, so first let's navigate to the external apps directory that we created for both ivar and maft, and let's start writing our RAxML_clc.sh script. Okay, so to start things off here, I'm gonna include a small shebang statement to make sure that this is executed as a shell script here, and then I'm gonna start defining these positional arguments, the first of which being a RAxML input file, this being the sequence alignment to build the maximum likelihood tree from. So we're gonna have that be the first positional argument from the user. Next is the expected output file. So expected output file name and path, and we'll just call that RAxML output and set that as the second positional argument defined by the user. And just like with ivar and maft, since we're using the singularity image, we want to make sure that we make the working directory that temp directory that CLC Genomics server sets up when running these tools. So we're going to make this thing here and comment this out first. Change to CLC Genomics server external app temp directory. And so we can grab the temp directory name using that dir name. Dir name of that second positional argument. Okay, and then we'll just change to that temp directory. Okay, perfect. Then we'll give a little standard out statement here. Genomics server external location, and this is Raxaml version 8.2.12. Just to let them know that they were able to start things off correctly there. Okay, and then next is the Raxml executable itself. Okay, so starting off, we're going to do singularity exec command, specifying the staff B, singularity images, the staff B image that we just built a second ago. So Raxml, I think we called it 8.2.12.singularity image, and then our command. So again, Raxml HPC being the major executable. Model of evolution is going to be GTR gamma. Then the input sequence alignment file, so sequence alignment input. Next is the seed. We can just set this to 1, 2, 3, 4, 5, and then the appended name GTR gamma as well. All right, let me just make sure that's set. Okay, and that's the real core of our wrapper here. But then, just like with the other two, let's do a little if statement to check that the output file is created. So if this file doesn't exist, and we'll just call this RAxML output, then print a little statement to standard out. RAxML output not created, and then exit with exit status 1, and finish that loop there. And finish out that if statement there. Okay, perfect. So just walking through this really quickly, we are taking in 2 positional arguments. The first of which being a sequence alignment input file to build the maximum likelihood tree. The second, defining the anticipated RAxML output file. Then we're going to change to that temporary directory to make sure Singularity is run properly. And then we're going to actually run Singularity to execute that RAxML command that we specified at the beginning of this step. And then we close off to make sure that the proper output is created. And if not, printing something to standard out that could be helpful for troubleshooting moving on. All right, so once we close this out, let's also make sure that we give executable permissions to this shell script there. And so with that, step 2 is complete. All right, so the third and final step to creating this external application is to configure everything using this genomics server web application. So if you're logged in as an admin user, you can go ahead and navigate to external applications. And I do have my RAxML external app already configured here, but I'm going to go ahead and click new configuration so I can show you the steps I took to set my tool up here. So the first thing here is to start by naming the application. So we can call it RAxML version 8.2.12. And then next we're going to fill out the command line with the shell script that we just generated with the 2 positional arguments. So it is in our ops directory, external apps, and we called it RAxML clc.sh. And then that first positional argument is actually that sequence alignment input file that we will create the maximum likelihood tree based on. And once we close that curly bracket, you can see that populate there in that general configuration tab below. And then next is the RAxML output file that we expect to be generated here, and that also gets populated down here below. So that first argument here is going to be user selected input data, and it should be a FASTA alignment file coming into RAxML. And then this RAxML output variable is going to be the output file generated. And we are going to call this the expected output file. I think it's RAxML underscore parsimony tree. And then we had that GTR gamma appended based on the wrapper script we defined in step 2. And this is actually going to be a Newick file. So this is a tree that can be rendered here on CLC. All right, so that's all that we need to do. Single input and single output with a tool like this. This is really how simple it could be to configure these tools. So with that, you would hit save. Oh, before I do that, actually, I always like to make sure that I do have the standard out pushed to a plain text file. So that can be very helpful for troubleshooting moving forward. All right, so with these settings and these external commands, you should be able to hit save, and step 3 is complete. All right, so to close off this final video, let me just show you what that RAxML external application will look like for your genomics workbench users. So you can see under external applications, I have that external app for RAxML available right here. And when I click that, it is a CLC server application, and you see that the single user selected input available to me is that sequence alignment input file. And actually, I'll be able to input the mapped multiple sequence alignment into RAxML to build this tree. So we can actually kind of string these tools together in a workflow. All right, so mapped MSA, and I think that's all I need to, oh, and then define an output directory and let it run. Okay, and in just a few seconds, this application is complete. And again, you can see a log file here for the export of the alignment file to the CLC genomics server environment. Here again is our standard out that we wanted generated for troubleshooting purposes here. And here is our final parsimony tree generated from Raxaml. And there you have it. So that is all the steps you need to take to create an external application for Raxaml. Hopefully throughout this 3-part series, you were able to see that this is the steps to make RAxML External App, but really it's the same steps to make any external application on your genomics server environment and have these tools accessible to your genomics workbench users. So thank you guys for taking the time to watch these videos. Again, if you have any questions, please comment below and we'll address what we can. Thank you all.